Okay, so today we're going to practice graphing. And I'm going to make a graph in multiple ways: graph paper, Google Sheets, Logger Pro, and Plotly. I'm going to make all those graphs, same data. Let me first show you the data that I want to collect. And it's actually a pretty cool experiment. So here you see I have this sled, and it's got, I think I have a cork bottom, and it's on the table. And then I can add different weights to there and pull it. So this is actually a video. Let's see if I run this. So you can see I'm going to pull it with the spring scale and read the maximum force before it starts to move. And so this gets up to, this one was, actually this may have gone over 10, but you get the idea, right? And so it's not perfect, and that's fine. And then so I'll pull it, add more weight, pull it, add more weight, and so I record the pull force as a function of the number of bars in there, and each of those are a 500 gram bar. And then since I don't have the same value each time, I repeat the thing 5 times. You could do a lot more. So each mass I repeated 5 times, and I have the following data set. Let's see, here's my data. I've already recorded it. I know maybe you wanted to do it with me, but I just went ahead and did it. So here's what I have. I have the number of bars, and each bar was 500 grams. I didn't actually measure the bars. I just assumed that wasn't true. That was in fact the case. And then I have, I'm going to delete that. I did this. I checked it to make sure it worked. We're going to fill it in. And then I have, for one bar, I have 5 different pulls right there. And then each 2 bars have 5 pulls and so forth. It up to 6 bars. And then each bar I put up here was 500 grams, 0.5 kilograms. And then my gravitational constant is 9.8. So I want to make a graph of the normal force pushing those two things together as a function of the force it needs to pull. So that's really what we looked at for the maximum friction force. We had that relationship: maximum static friction is mu times n. So we're plotting that friction force versus the normal force and see if it is indeed a linear relationship. That would be fun. It'd be fun, right? Okay. So let's do a little bit of work here. So the first thing I need to do is get the average force. If you're not familiar with spreadsheets, this will be useful for you. You know, the great thing about spreadsheets is that you can make a calculation in each cell. So I don't want to calculate on a calculator, although you could. I just don't want to do that. So in order to do a calculation in a cell, you say equal, and there's some built-in functions that we can use. I'm going to use the average function. So I just type average, and you'll see it pops up right there, and it'll tell you what it is. And then I just need to give it all the values I want to average. I, in fact, want to average a lot of values, so I can actually highlight these. Oops. Let's highlight all of these right there. That's 5, right? Yep. And then close parentheses and press return. And it gives me the average. And also it says, hey, I think I know what you want to do. Google does this and it says, do you want me to just finish it for you? Because I see what you're doing. And I'm like, yes, do that, please. So then I have the average force for all of those. One of the things that we also like to do when we collect data is to look at the uncertainty in the force, since there's some variation. One way, not necessarily the best, but one way is to report the uncertainty as the standard deviation of this data. So I'm going to do that. So right here I have df is my uncertainty, and each one has different values. So I can say equals stdev, that's the standard deviation function, and then I'm going to highlight all of this. And so see, you'll notice it says E3 colon I3. That means cells E3 through I3. Close parentheses. Oh, didn't like that. Name. STDEV, not EDV. And then highlight that. Close parentheses. Yes, please fill it. So now I have my force and my uncertainty. I'm going to actually plot the uncertainty in some cases. Right here, it's fairly high, 0.4 out of 8.3, but we can use that as error bars. Now, the other thing I want to do is to calculate the normal force. So I have the number of bars. I need to multiply that by 0.5 kilograms, and then I need to multiply that by 9.8. So let's say equals this, and yes, I didn't include the mass of the bucket. That'll be something we can talk about. Times the mass per bar, which is this right here, times G, which is that value right there. Now, I want to copy that down, and I'm going to change the values on the A column, but I don't want to change these. These are constants. So I can put up here, I can say in front of the 3, I can put a $sign. No. Right over here. C $1, E $1. So that means when I change it, don't change that number. Okay. And it says you want to fill. And so you see right here, this is, if I click on this cell, it's A8, which is this right here, divided by, multiplied by E1 and C1. So it's still using those same ones. So I have my normal force. I have my average force. I'm going to graph this. Yes, you can graph this right in Google Sheets, and I'm going to do that. But I'm going to first do it on a paper, because I think it's important to understand what's going on with the graph by doing it on paper. So let's switch over to the paper and make a graph of this data. So I have this data on my computer, so I'll see it. But if you won't be able to see it because I'm switched to the paper. See, you can't see it. Okay, so let's make a graph. I have graph paper here. I'm going to just go ahead and make an axis. You could use the whole graph, but I'm just going to randomly pick stuff. And if it's not the best ever graph, I'm okay with that. So I'm going to use this point right here as my origin. And then I'm going to move this way. So I'm going to draw a line. Sorry, I can't see too well. And then this is going to be my vertical axis this way. And I don't know why I picked it. And if it turns out to be too small, that's fine. Okay, so now let's consider. So I'm going to say I want to look at F friction max is mu s times n. So I want to plot the pull force on the vertical axis and this on the other one. That's the way it looks like y equals mx plus b, and then m would be, the slope would be that. That's what I'm doing. Okay, I just want you to know ahead of time what I'm doing. So this is going to be my FP in newtons. So if I look at my graph, my data, I have values from 4.9 to 5 to 30, about 5 to 30. So let's just say this is 5. Then I have 1, 2, 1, 2. Let's just do, if I did 5, if I did 1, 2, 3, 4, 5, and make that 10, right? So each one of these would be 2. This would be 15. So let's just put that. 15. 1, 2, 3, 4, 5. That'd be 25. 1, 2, 3, 4, 5. That'd be 35. And it goes up to 30. So I remember in middle school making a graph, and my science teacher was like, if it doesn't take up more than half the thing, you could always make the scale twice as big. But I'm not going to do that because this is not middle school anymore, and I'm just showing you how to make a graph, not the best graph. Because look, if I might be able to make the scale bigger, but that's fine. So I said this is 5. And you don't have to start at the origin. You don't have to start at 0. You don't have to do that. You can, but there's no data down there, so I don't really care. Now for the normal force, which is over here in newtons, which looks weird, I go from 1 to 9. So let's put this at 1. And then 2, let's do this. 2, 3, I'm going every other one. 4, 5, 6, 7, 8, 9. And again, it's not the biggest graph, but it's not bad either, right? It's not some tiny little thing. So you don't have to start at 0, but you do have to have these evenly spaced numbers. Okay, so now I just have my data points. I need to plot them all. So my first one is F is 1 point, N is 4. Oh, I got those backwards. Crud. Okay, this is F. So that's fine. I'm a bad person. That's fine. FP, and this is N. I was just excited. So that means this is not going to work. That's fine. We're going to fix it because I don't want to make a new graph. I don't want to waste graph paper. Okay, so I'm plotting F on the horizontal axis, which is a bad idea, but I'm going to do it anyway. I could just rotate the paper too, but I'm not going to do that. So my F value is 1.5. So that's right here. 1.5. 1.56. I'm just going to do 1.5. Doesn't have to be perfect. And 4.9. So that's going to be right there. The next one is 3.07 and 9.8. So 3.07 is close to this. And then 9. So this is 5. This would be, I should have done, this would be 1, 2, 3, 4, 5. So 10 would be 7. That's weird. What did I do? Did I do 2.5? See, 1, 2, 3, 4, 5. So each of these is 2. So that's 7, 9, 11. That's right. So that's 11. So 10 is in the middle. So that was dumb. Okay. And then I had, what, 3. So I'm over here. And then I had 4.15. So I'm right over here. And 14.7. So that's almost right there. That's not a point. And then I had 5.8. So I'm over here. And 19.6. So 20, that's going to be 23, 21. And then the next one's 19. So it's kind of in the middle. It's not perfect, but it'll work. 7 and 24.5. So there's 25. And then finally 8.35, which is around here. And 29.4. So this is 25. That's 27. That's 29 right there. A little bit higher. Okay, so there's my data points right there. And that's a pretty good graph. The next thing I want to do is to find a best fit line. And then this is important, right? This is not a data point. I want to take a straight edge and find a line that comes close to as many of these data points as possible. It does not actually have to touch any of them. Don't go from the first to the last. Just draw kind of, approximate. It can touch them, but just the best. And this is just a best fit line. It's not, you're not doing a calculation, you're just kind of eyeballing it. So I'm going to pick it about right there, and I'm going to draw my line as long as I can, like that. Now I want to find the slope. Now let's go up here to my equation. I have F friction equals coefficient of friction times the normal force. But I'm actually plotting normal force versus friction. So I'm going to divide both sides by mu, and I get N equals 1 over mu S times the friction force. And so that means this looks like Y equals mx plus B. So if I plot N versus this, the slope would be 1 over the coefficient. So I need to find the slope of this line. So how do we find the slope? Well, the first thing we want to do is to pick points on the line that we drew. Do not pick the points you used to draw the line. Otherwise, there's no point in having the line. Okay, so I'm looking for ones that cross 2 lines right there that make it easier. And then and far apart as possible too. And that would be perfect, but right there. Okay, so slope is going to be delta N, the change in the vertical, divided by the change in the horizontal. So let's see. N over here is 37 minus this N, which is 7, 9, divided by this horizontal value, which is right here. So it's going to be 10.5 minus the value right there, which is going to be 2.5. Okay, now I do want my calculator. I'm doing this the old-fashioned way, right? That's why I have my calculator. So let's turn on the calculator. I just went to calculate that. 37 minus 9, which I could do in my head. Cancel. I got to put parentheses. 37 minus 9, close parentheses, divided by parentheses. 10.5 minus 2.5, close parentheses, equals. And that would be, what's that say? 3.5. So mu S is 1 over 3.5. That's the coefficient of friction. So let's just do that. There's a way you can just do that, but I don't know. 1 divided by 3.5 equals. And I get 0.286. I can't read this thing. Yeah, 0.286. 0.286. That's my coefficient of friction. Now, so doing this on the graph, the nice thing, again, it helps me understand what's going on. I'm not doing a program and just graphing that thing, okay? I understand that each one of these data points has a horizontal and a vertical and a horizontal value. So that is important. This is the kind of thing that I would ask for in a test. I would ask for you to make a graph. I don't have my students use some program to make a graph. Using a program, I think, is just a shortcut once you understand this. So make sure you understand this. And this is the most important thing too. Finding points on the line I drew. Don't do these 2 points. Don't do these 2 points. Otherwise, what are all the points in the middle even do? Okay, now if I wanted to write the error bars, let's say for the last one I had the error bars of 0.4, then certainly it's 0.4. So this data point right here, FP is plus or minus 0.4, which is almost one of these bars. So it's actually, it would look like that. That'd be my error bars. Okay, and each one of those have error bars. Normally they're kind of small and not worth pointing out, but I will show you how to do them in the other, at least in two programs. So let's switch back over to this Google Sheets, and let's make a graph. Now, I get forgetful on how to do these things, so let's just see if I don't make a mistake. Things do change. So I'm going to highlight the data I want to graph right there. And now I'm going to insert chart. Now, here is a big thing that you have to worry about. I don't want a column chart. I clearly don't want that. I don't want a line either. A line is not what you want. You want what's called an XY scatter or scatter plot. And there's my scatter plot. Okay, so now this you can see goes up to 10. So this is, I am plotting FP versus N. I always get that confused too, and for me, I get confused about which way it plots, but you can change that right here. What I want to do is to go to Customize, Series, and I want to add this trend line, which is a best fit line. And so there is the best fit line. And the slope of that line I can get to if I go down here to Label, Use Equation. So there you go. And there I am done. I'm not done really because you need to add these labels and stuff like that. And for some reason it looks super big. But there you go. And you'll notice that the slope of this, 0.278, I had 0.286. So that's close. That's pretty close. I'm pretty happy. Okay, let's go and do the other program that I like to use that I think is really good is Logger Pro. For if you have a site license for that, students can install it on their own computers, which I think is super awesome. And I think it's a very good graphing program. So I'm just going to highlight this. I have N and F. I'm going to copy that. I'm going to go over to Logger Pro, which I already have opened up, but you can't see it because it's up here, right there. And then I'm just going to paste that into my data column over here. And then I'm going to change this X. So I'm going to double click on that. I'm going to say N, that's the normal force. And I'm going to have short name of N, and the units are going to be N. Okay, that's fine. And then over here, I'm going to plot changes to F, 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 F. I guess I could call it friction. And then N. Let's do that. Let's call this friction. And I'm sorry, it's a little bit, I'm not sure why it's so small, but can I make that bigger? No, I can't. Okay, there's probably a way to make it bigger. And then I'm going to double click this and change this to normal force. You can't even tell I type it wrong because it's so small. Okay, done. Now, there is a way to add, now you'll notice it already made my graph. You can't really see it very well, but here's friction versus normal force. Now, that's what I want, right? So let's go ahead and add a best fit line to that. There's a couple ways you can do that. I'm just going to click this button up here, and this says linear fit, and it fits a line. and it gives me a slope of 0.2777. And that's different than the spreadsheet because there are different ways to calculate this best fit line. It gives me an intercept. Also look at the intercept of 0.2433. So ideally, if you had no normal force, the friction should be 0, but it's not. And there's a couple reasons. Number one, there's some uncertainty in the fit. And number two, I mean, that is kind of like the mass of the weight of the bucket by itself. And that'd be fun to check. Take that, divide it by 9.8, and it'll give you the mass, and then go find the mass of that bucket and see if that's what it is. If it is, I think that's a big win for me. Okay, error bars in here. So let's see, I had error bars on the frictional force. So let's see, if I go to options, error bar calculation. Okay, so you can use a column. So let's go over here and let's make this graph a little bit smaller. And let's make this a little bit bigger. And let's go to, you can't see it, it's up here, data, new manual column. I'm going to call it DF. And it's going to have units of newtons. Okay. Now I'm going to go back over to my spreadsheet right here. And I'm going to copy my uncertainties. Copy. Go back to Logger Pro and paste those in right here. And then I'm going to go to my friction column right here, and I'm going to say options, use error bar calculation, use column, and I'm going to use DF. Done. And there you go. There are my error bars. And you'll notice they're in the vertical direction because I have friction on the vertical axis. And that's kind of cool. Okay. Now, actually, if I go up here and I do this button, and this curve fit, and I choose linear, weight column by DF. I think it will take into account the uncertainty too. Try fit. Okay. Okay, so let's see. That gives me a linear fit of 0.2759, so it's very close, but it does give me an uncertainty now. So that's kind of cool. I like that. Okay, one more way to graph. Let me just go ahead and grab this data again. So here's N and F. And I'm going to go over here. So this is Plotly. So Plotly is an online graphing tool that actually, the thing I love about Plotly is that you could take code that you write in Python and send it to Plotly to make super nice graphs. And in fact, we could make this graph in Python. I should do that, but I won't do that. But I should. I want to, but I'm just going to do it straight in this. And so I'm already logged into my account. You can make a free account here. And up here, it's chart-studio.plotly.com. That's where you want to go to, and then sign up. And now I'm going to go over here to create a chart. And it looks a lot like a spreadsheet thing, but that's fine. I'm going to paste my data, so then I can rename this, but I'm not going to worry about it. I know that that's, wait, which one is that? This is N. N is on the left. Okay. Now I'm going to do add trace. And I want to scatter. Now I have to pick my x-axis. I want my x-axis to be B. Is that right? And my y-axis to be A. No, I want it the other way. So I want this to be A and this to be B. That's what I want. Yeah. Okay, so there you see we have the graph already down there. The great thing about this is you can customize this in a lot of different ways. But let's say put a title, pulling a box, put a label right here, frictional force in newtons. You can type whatever you want. Normal force in newtons. That's that. And then I can change the size and all that. If I want to make those dots a little bit bigger because they don't look super big, I can go to general. This is text. Title. Oh, traces. Point size. It's at 6. See, I can make them bigger. I like that. Okay, so now we want to fit a function to that. So I'm going to go to Analyze here on the side, Curve Fitting, and then Add Fit. Now you have to tell it what function you want to fit it to if you have more than one function. I only have one, so it's just called trace 0. And then I want to use a linear fit. Now, one of the things you have to do is you have to give it a guess. It can't fit without a guess, so I'm going to say 1, 1, and then I click Run, and it fit it. It didn't give me the slope, though. You can see this. Oh, it is right here. This is the slope right here. So it has a slope of 0.277, so the same as the other ones, and an intercept of 0.243. So it agrees. I'm pretty sure you can add error bars in here too, but I don't want to do that. I want to end the video because I want to keep it under 30 minutes. Okay, so that's Graph Paper, Google Sheets, Logger Pro, and Plotly. Personally, Graph Paper is the number one thing if you need to know how to do it on Graph Paper. And the second one I would use is Logger Pro, just because if you have that program, it's super easy to change things up. It's super easy to make graphs, and I like that the best. So my least favorite would be the spreadsheet. I'm just not I used to be a huge spreadsheet fan, but I'm kind of like meh now. So, okay. Hopefully that helps.